Now let me give you another example of a simply supported beam. This is a simply supported beam that is supported by some supports. Let us take roller support. Okay, and a force is acting on its center. Length is L by 2 here, L by 2 here. Let us say this reaction as RA and this reaction as RB. Okay, since it's acting at the center, so the problem is symmetric. So RA will be P by 2 by symmetry. RB will also be P by 2. Now let us make this shear force diagram for this. Shear force diagram, it is denoted by Vx and X. Okay, what is the force acting at the origin at this point? It is P by 2 in the positive, in the upward direction, that means positive. So it will be plus P by 2 here. Now no force is acting on from 0 to L by 2, so it will be constant till this, constant at this point. Till this point it will be P by 2. Now the force P is acting in the downward direction, that means negative. Negative means negative P plus P by 2 minus P, that is minus P by 2. So minus P by 2. Now from this point to this point there is no force, so it will again be constant. Now at this point this is acting in the upward direction, plus P by 2, so plus P by 2, it comes out to 0. So this will be positive direction, this will be negative direction, and the magnitude is plus P by 2 and minus P by 2. So this is the shear force diagram for a simply supported beam where the force is acting at the center of the beam. Okay, now let us make the diagram for bending moment. Bending moment will be like this, mx and x. Okay, now to say in the same way we need to take a section xx. Let me make a smiley face, that means you are at this section. Imagine yourself to be at this section. So this reaction force, which shape is this force making of this beam, of this part? It will tend to bend the beam in this direction, so it will create sagging. You need to imagine that in what shape this force will bend the beam. It will be creating now sagging shape, so it will be taken as positive. So let us write the equation for x from 0 to L by 2. Mx will be plus Ra into the distance x. This distance is, let us take as x. So mx will be plus Ra into x. Ra is P by 2 into x, so plus P by 2x. At x equal to 0 it is 0, so it will be 0. Now it is varying linearly. At x equal to L by 2, at x is equal to L by 2, mx will be PL by 4. So it will be varying linearly p till PL by 4. PL by 4. Okay, now in the same way it will be now decreasing for L by 2 to L. Mx will be what? Now the section will be here, now you are here. So now the what is the equation that we'll be writing? Now the bending moment that is being created by this reaction is the same. This distance is x now, so this is Ra into x in the positive direction. Now this force is creating a bending moment in the negative direction. It tends to bend the beam in this direction. It is creating hogging shape, so it is taken as negative. Okay, negative means P into this distance is how much? This is x, this is L by 2, so x minus L by 2, x minus L by 2. Solving this, P by 2 into x minus px plus PL by 2. This is PL by 2 minus px by 2. Now x varies from PL by L by 2 to L. At x equal to L by 2, mx comes out to be PL by 2 minus PL by 4. It is PL by 4, the same as we got in the earlier case. At x equal to L, we get mx is equal to PL by 2 minus PL by 2, it is 0. So it will be varying in like this. PL by 4 at this point, 0 at this point, very linearly. So this is this. Now this is positive since it's in the upward direction. So the bending moment diagram for the simply supported beam is this shape. Okay.